A huge thank you to all the super sponsors who make it possible for me to make these videos. Visit David X Newton on Patreon to join the ASCII Brigade. At this point in the series, we have a system by which we can exchange orbs dropped by monsters for health points. Let's now spend some time adjusting how it works by showing how we can manipulate actors in the game world. The player's got a continuous source of health points now, so let's go power mad and remove all the other health-giving items from the maps. ZScript gives us the ability to search through the thinkers that exist in the game without having to address them by a pre-approved tag number. To do this, we're going to use a thinker iterator. This works by having it specify a filter when it's created, such as looking for all imps or tech pillars or just everything, then repeatedly calling the next function on it and performing our operations on the returned actors until there are no more search results. We want this to happen at the start of the level, so once again we're going to create an event handler. This one will be called Orb Setup Handler, and it's going to listen for the World Loaded event. This one's similar to the open or reopen script types in ACS, and it will be called when the level has first been initialized. When that happens, we want to create a new thinker iterator by calling the thinker iterator create function. The first argument it needs is the name of the class to start searching from. We're interested in the GZ Doom class Health and all of its descendants. In Doom, this will include medikits, stim packs, soul spheres, and the health bonus potion bottles. There's also the Megasphere, but it exists under the power-up class and not health, so we'll leave this one alone for now to avoid complicating things. The second argument is a stat num, and these are a way GZ Doom uses internally to group thinkers together. You can see the list of them on the ZDoom wiki. We could leave this second argument out and have the iterator just search through all the thinkers in the game, but it's nice to be as efficient as we can. Passing stat default will limit the search by just looking at the default category and ignoring any thinkers that handle dynamic lights, decals, sector movement and effects, or other special cases, and this will greatly narrow down the search. We're now going to use this iterator to loop through all the thinkers in the game that matched its criteria. We'll set up a variable of type health and call the iterator's next function for the first time to put the first found object into it. Then, as long as the item is not null, we'll do what we need to do with this item and then call next again. When the iterator has no more results, it will return null into the item variable, and this will break the loop. Before we write the body of the loop, this is a good place to talk about what's called casting. If you run this code as is, you'll get a complaint that a class of thinker can't be converted to a class of health. The thinker iterator could potentially give us any thinker or its descendants, depending on what its filter was when it was set up, so its next function returns values of type thinker. Often this isn't very useful to us, because if we only know the object is some kind of thinker, then we can only do things to it that are part of the base thinker class. Making changes to things like amount of health awarded, or other properties that are specific to health classes will be off limits to us, because not all thinkers have these properties. But here, the iterator is only searching for objects that are of type health, so we know that the thinker returned by the next function will always be a descendant of health. Therefore, we can tell ZScript to treat this object as a health item by casting it, and here that's done by enclosing the object in parentheses and prefixing it with the name of the class to cast to. In the loop, we're going to output a console line for debugging, just to show we're doing something, then destroy the selected item. Both these actions are of course available on the base thinker class, but it pays to get into the habit of casting your results from an iterator so that they're actually of the type you expect. Now add this event handler to our list of global event handlers in game info, and we can now test this arrangement. Now, when starting any map, you should get a set of messages about removing health-related items, and you'll notice their absence as you walk around the level, making the player much more reliant on our orb system. Once you're satisfied it's working, you can remove the printf line that we used for debugging. If you feel like removing Megaspheres as well, you can add a second iteration where you search specifically for the Megasphere class. Just to be cheeky, I'm going to use the spawn function here, like we did with the orbs earlier, to leave a single health bottle in the Megasphere's place before destroying it. This time, we don't need to perform any calculations on the position, and we can just directly use the Megasphere's pause to pass into the spawn function. So now we have a variant of Doom where the supply of health comes almost entirely from monsters, and where some of the secrets are a lot more disappointing. Let's see what else we can do with our extended access to actors and their properties. One thing you'll have noticed is that there are definitely a lot of orbs to collect from bigger monsters and encounters. Seeing an absolute explosion of them and wading through them can be fun, so I wouldn't judge anyone for enjoying this as is, but for the sake of the tutorial, let's see if we can make some adjustments here. Let's say if we needed to create 10 orbs, we'll instead create a special bigger orb in their place. You could do this by making a separate class that gave you more orbs when it was picked up, but in ZScript we have more options because we're allowed to change the data on a specific object once we've got hold of it. The sheer number of variables that an object has to play with is another area in which the ZScript documentation doesn't do all that well, because there are just so many of them. However, looking at the source code can give us some clues. By looking at the definition for the inventory and actor classes, we can see two variables that we might be interested in. The actor's scale, which is a vector 2 called scale, and the number of inventory items that it grants called amount. So let's go back to our DoomOrb class so that we can write a function that will make the orb designate itself as a bigger orb. Unlike everything else so far, this function is entirely made by us and doesn't override any functionality that's in any parent class, so we can call it what we like. I've chosen makeBig here. This function doesn't have any parameters and it returns nothing, it just alters the scale of the object and the number of inventory items it grants. Remember that self is a keyword that refers to the object that this function belongs to. While I'm here, I've also removed the orb pickup message by setting it to an empty string, because I'm sure it was annoying you as much as it was me. Now that the DoomOrb has the ability to upgrade itself, let's go back to the function in the monster death event handler where we spawned our orbs. We want to alter this so that for every 100 health points the monster has, we'll drop an orb and then call makeBig on it to turn it into the bigger variant. Then for every 10 points left over, we'll drop the standard orbs without changing them. The first thing we'll have to do is apply some casting, just like we did for the iterator earlier. The spawn function returns an actor which doesn't know about the specifics of inventory or DoomOrb, including the makeBig function we just wrote. So we'll cast the result of the spawn function to a DoomOrb before we do anything with it. After that, you can feel free to adapt the function and write your own logic here using as much or as little of the idea that I just described as you like. The syntax is much the same as in Java or C#. This is my own attempt here. Now, we start by putting the monster's max health into a variable called remaining health and run a while loop as long as our remaining health is above or equal to 10. On each loop, we create a DoomOrb, then if we have 100 or more health points left to account for, we'll call makeBig on it and subtract those 100 health points. If we don't, we'll leave the orb alone and just subtract the normal 10 points. We then apply the orb velocity, whatever happened above. This loop will continue until we have fewer than 10 health points left over. Now, as you're tearing through the bigger enemies, you'll see some larger consolidated orbs taking the place of the small ones, and those larger pickups will award 10 orbs each. One more thing we can add while we're talking about functions in our actors is adding our own action functions. These behave like the functions beginning with the capital A that are callable from Decorate, and they can be added to the list of states in the same way. Let's say that we want our DoomOrbs to enter a new state shortly before they disappear where they flash more urgently, so the player can tell they're about to miss them. Here I'm writing a new state label called Decaying, where we'll swap more rapidly between the orb's 2 frames and the built-in blank sprite called TNT1. Our new action function will cause our orb to jump to this state label if the orb's age is sufficiently large. Action functions are specified slightly differently from other functions. They're specified with the keyword action, which gives them special properties that allow them to distinguish between the actor that's calling them and the class that the function actually belongs to. This is important in situations like when a player is calling an action on an item that's in their inventory, although in this case we don't have to worry about this possibility because the action is always going to be called by the inventory object itself. But as a result of this distinction, inside action functions, the object calling the action is now known as invoker instead of self. So in here we'll check the age property of the invoker. If it's greater than 250, we want to set the state of the invoker to whatever the first state is under the decaying state label, which we retrieve by using the resolveState function. Now we just need to add a call to this new action function in our first loop of states. We'll check it each time we're on the B frame. Start this up and test it for the last time this video, and you should see the orbs starting to blink a few seconds before they're removed from the game. It's possible to get as fancy with this as you like. In this example here, I've added a max age variable so that I can make the bigger orbs last longer than the smaller ones. The initial value for the maximum age is set in the overridden postBeginPlay function, which is called on actors just after they're added to the game world. I've then had the orb change its maximum age as part of the setSize function, and the checkAge action function now checks to see if the orb is at whatever its max age is, minus 100. You can experiment and add variations however you like. We've now done a lot of manipulation to actors by searching for them, removing and replacing them, writing our own functions and action functions, and jumping around in their state tree. Next time we'll add a new mechanic to the game by moving up from actors in the class hierarchy and writing our own thinker.